Hey guys, today we'll be seeing question number 1 on LeetCode, to sum, a very popular question. Here we are given an array of integers and we are given a target integer. And we need to find two numbers in the array such that they add up to the target. We will be returning the indices of the two numbers, and for this solution, we will be returning the smaller index first. Also, we are given two important things in the question. First, there is exactly one solution, and also that we cannot use the same element twice. So our answer would be exactly 1 and there would be two distinct indices. Having a look at the example, the first example has a target of 9, and from the array we can see that 2 and 7 add up to 9. Hence we return the index 0 and the index 1. For the second example, we have a target of 6. 2 plus 4 add up to 6, hence we return the index 1 and the index 4. Keeping in mind, we cannot use the same element twice, so we cannot use 3 plus 3 or return 0, 0. That would be completely wrong. For example number 3, we have a target of 6, and as there are just two numbers which add up to 6, we return 0 and 1. Again, 0 or 0 and 1, 1 would be wrong answers. Now the most intuitive solution that comes to my mind is picking each number and checking through the array to see if there is any other number which adds up to give the target. So for that, we run two loops, an outer loop starting from the first element, an inner loop j that runs from the next element to I. We check 6 plus 3 do not make a 5, we increment j. 6 plus 1, again not 5. Come to here. 6 plus 2, again it's not a 5. Our j reaches a dead end, we increment I to the next number. Again we go checking j from I plus 1. 3 plus 1 is 4, we increment the j, and 3 plus 2 is 5. We have found a pair, and since we know that there is only one solution, we know this is the answer. Now one thing to note here is j would always be towards the right of I. Now having a look at the code, an outer loop running from 0 to the length of the array and an inner loop running from the next element from I till the end of the array. We check if both add up to our target. If yes, we return I and j, and we know I is the smaller one and j is the larger one. Now the time complexity here is O(n) square. As for each element in the array, we are checking the whole array again. So I loop runs n time, and for each I we have the j loop running n time, hence the complexity n square. The space complexity is 1 as nothing new is being made. Also, since we know that there has to be a solution, we would always be returning through this and a cursor would never be reaching this line. Now a second method that could come to us is what if we sort our array and we use two pointers and iterate through the array till the sum of the two pointers returns back the target. As we need to return the indices, we need to preserve the index in the original array before sorting. So for that, we would be creating a 2D array. The number of rows would be equal to the size of the array. So creating a 2D array, we would be having something like this. Since there are 4 elements in this example, there will be 4 rows in our 2D arrays and 2 columns, one for the number and second for the index in the original array. So we iterate through the original array, saving everything in the 2D array. 6 at index 0, 3 at index 1, 1 at index 2, and 2 at index 3. Now we sort this according to the 0th column of each row. We would result in something like this: 1, 2, 2, 3, 3, 1, and 6, 0. Now for this 2D array, the rows we know are the length of the original array, so 0, 1, 2, and 3, and the columns are 2, so 0 and 1. Since we have now sorted our array, we would be running two pointers, one at the start and second at the last element. So our ith pointer points to row 0 and our jth pointer points to row num's length minus 1. Now we add the 0th element in the jth row and the 0th element in the ith row. The sum 6 plus 1 is 7, which is greater than our target. So we need to reduce the number. And since we know that our array is sorted, we need to decrement the pointer pointing at the larger object, which is the jth one. Hence, we move the j, we decrement the j, and it now points to 3. We then again check the sum of the 0th element in j row and the 0th element in the I row. The sum 3 plus 1, 4 is less than our target. And since we need to increase, we would be incrementing the pointer pointing to the smaller number, which is I. Now our I points to the next element. We add the 0th element in the I row and the 0th element in the j row, and 3 plus 2 is 5. We have reached the target. We return back the two indices I and j. Now since for this question we are returning the smaller index first, we compare the value at first index in the ith row and second index at the jth row. These were the original indices in the original array. So for that, we first return the minimum of the first one in the ith and the first one in the jth, and the second one the maximum from the first column in the ith and the first column in the jth row. Now having a look at the code, we start by creating a 2D array A whose rows are equal to the length of the original array and column is 2. We iterate through our array and add the number at the 0th location and the index at the first location. We sort our array. This basically sorts a 2D array in ascending order based on the first element of each subarray. Here, A represents each row and A0 represents the first column. And comparator.comparing int tells Java to sort using that value. Moving on to our pointers, our first pointer is at the 0th row and our second pointer is at the last row. While I is less than j, so that both the pointers do not cross each other, we take the sum of the 0th element in the ith row and the 0th element in the jth row. We store it in a current. If current is equal to target, we return both the index in the required format. If not, if it is less, we increment I. We need to increase the target. And else, if it's greater, we decrement j, as we need to decrease to reach a target. And since again there is always one solution, we would be returning here and our cursor would never be reaching this location. Now the time complexity for this part is n, as it is iterating through the original array, storing it in the 2D. The sorting in Java takes n log n time. The two pointers again take n. The two pointers again take n times, as they're iterating through the n rows in the 2D array. So n plus n log n plus n gives us a final time complexity as n log n. The space complexity here is O(n), as our 2D array is being creative. So O of 2n gives us O of n. A third way is using HashMaps. So in HashMaps, we store in pairs. We have a key and a value associated with it. So we create a HashMap. We iterate through our arrays and we add each element along with it in its index. We iterate through our array and check for each element if target minus that element exists in the HashMap. So running a loop, our I starts at 0th position. We check if target minus I, that is 5 minus 6, exists or not. It doesn't, hence we move our I. We again check if target minus I exists. In this case, it does. Now one common mistake we may make here is we may check the number with itself. For example, for an even number like 8, if the array has 4, we might check 4 with itself and return back the same number twice. So we also check the index. We compare I with the value of the key, that is 3. Our I here is 1 and the key here is 3, and since these both do not match, we return back our answer. If it matches, we move on forward incrementing the I until we reach a solution. Having a look at the code, we create a map of integers called indices. We iterate through an array, adding each element and the index in the hash map. Then we run again through the array from 0 to length. We compute the difference using target minus nums I. One thing to keep in mind is we need to be subtracting the number from the target and not vice versa. Nums I minus target would give us a different number with an extra negative sign. Now after computing the difference, we check in a hash map if it contains the difference. If it does, we also need to make sure that the value or the index is not equal to I. If not, we return back I and the value the key is mapped with. In this case, since we are checking from left to right, we know that I would always be smaller than the second value. The time complexity in this case is O of n. Adding elements in HashMap takes n time, and checking the element also has worse time complexity of n. Inserting as well as checking the key in HashMap takes constant time O of 1. Hence the time complexity 2n is n. The space complexity is O of n as the HashMap created is of length of the array. Now another optimal way of solving the same thing could be if instead of adding every element in the HashMap beforehand, we take the current element, check if the difference exists. If yes, we return. If not, we add that element and then move on to the next. This would save us the trouble of going through the array twice. So we start with I 0 up till nums. So I starts at the first element. We compute the difference of the element and the target, also checking that the difference exists in the hash map before we insert the current element is important to avoid comparing the same element with itself. Hence we check if it contains the difference, we return back the index of the difference as well as I. Now in this case, we know I would always be larger. First, we check 6. The difference minus 1 does not exist. We move on adding 6 to the hash map. Then 5 minus 3, 2 doesn't exist yet. Hence we move on adding 3 to the hash map. Then we reach 1. 5 minus 1, 4 doesn't exist. We move on. When we reach 2, 5 minus 2, 3, which already exists in the hash map. Hence we know in this case I would always be the larger one. Hence we first return the value of the key difference and then I. If not, we insert the value and the index in the map and increase the iteration. The time complexity again is n since we are running through the whole array once, and the space complexity is also n since the hash map is created of size length of array. I tried covering all possible solutions and I hope I was able to explain them. If you have any more different methods or any feedback or suggestions, do comment down.